Imagine looking up at the night sky and seeing a galaxy millions of light years away. Pretty normal, right? Now, imagine seeing that same galaxy, twisted, duplicated, or even stretched into a perfect, shimmering ring. What if I told you this isn't some bizarre cosmic magic trick, but a fundamental distortion of reality caused by something you can't even see? What if the universe itself is lying to your eyes? To understand this profound cosmic illusion, we have to travel back in time, not to some ancient civilization mapping stars, but to the mind of one of humanity's greatest thinkers, Albert Einstein. In 1915, his groundbreaking theory of general relativity didn't just redefine gravity as a force, but as a curvature of spacetime itself. Think of spacetime as a giant, invisible trampoline. Place a bowling ball in the center, and it creates a dip. Now, roll a marble across that trampoline. It won't travel in a straight line, but will curve inward, drawn by the dip created by the bowling ball. In Einstein's universe, massive objects like stars, galaxies, and gigantic clusters of galaxies are those cosmic bowling balls. They warp the fabric of spacetime around them. And here's the crucial part. Light, the fastest thing in the universe, is not immune to these distortions. Light, which we've always assumed travels in perfectly straight lines, actually follows the curvature of spacetime. So, when a beam of light from a distant galaxy passes near a colossal celestial object, its path is bent, just like the marble on the trampoline. This phenomenon, once a wild theoretical prediction, came to be known as gravitational lensing, and its implications are nothing short of mind-bending. It's as if the universe has its own set of natural magnifying glasses scattered across the cosmos, revealing secrets we could never hope to see otherwise. Now, let's peel back the layers of this cosmic mirage. This isn't just a simple deflection, it's a complex reshaping of the light we receive. When light from a very distant source, like a bright quasar or a background galaxy, travels towards us, and a massive foreground object, like a galaxy cluster, happens to lie directly in its path, that light gets bent. Instead of arriving in a single, clear image, the light takes multiple paths around the lensing object, arriving at our telescopes from slightly different directions. The result? We see multiple images of the same distant object, or sometimes a single object stretched and distorted into an arc, a smudge, or even a stunning, near-perfect circle known as an Einstein ring. These rings are arguably the most beautiful and direct visual proof of Einstein's theory in action. Imagine a colossal cosmic bullseye, formed by the warped light of an ancient galaxy, millions or even billions of light years away. It's not just pretty, it's a window into gravitational physics on the grandest scale. There are different flavors of this cosmic trickery. Strong lensing is the most dramatic, giving us those spectacular arcs and multiple images. It happens when the lensed object, the lensing object, and our telescope are almost perfectly aligned, and the lensing mass is enormous. Weak lensing is far more subtle, a faint, almost imperceptible stretching of background galaxies that can only be detected by statistically analyzing the shapes of hundreds of thousands of galaxies across vast swathes of the sky. It's like looking through slightly warped window panes. Individually, you might not notice, but collectively, the distortion becomes clear. And then there's microlensing, a fascinating subcategory where individual stars or even planets act as lenses, briefly brightening a background star as they pass in front of it. These fleeting events are incredibly difficult to catch, but offer unique insights into objects that are otherwise invisible. Each type of lensing, from the dramatic strong lenses to the barely detectable weak ones, paints a more complete and, frankly, weirder picture of our universe. The light isn't just being bent, it's being amplified, cloned, and distorted in ways that redefine our perspective on cosmic cartography. It's like discovering the universe has a funhouse mirror hall, but instead of for laughs, it's for revealing fundamental truths. But the real mystery deepens when you consider what gravitational lensing allows us to truly see. This isn't just a parlor trick, It's one of our most powerful tools for understanding the invisible universe. First and foremost, gravitational lensing is one of the strongest pieces of evidence for the existence of dark matter. Remember those cosmic bowling balls? When astronomers analyze the extent of the bending and distortions created by galaxy clusters, they can calculate the total mass within that cluster. What they consistently find is that there's far more gravitational pull than can be accounted for by all the visible stars, gas, and dust. This missing mass, which interacts with gravity but doesn't emit or absorb light, is what we call dark matter. Gravitational lensing allows us to map the distribution of this mysterious substance, showing us where it clumps together and how it shapes the very structure of the cosmos. It's like seeing the ghost of the universe, revealed only by its gravitational footprint. Beyond dark matter, gravitational microlensing has become an indispensable technique for finding exoplanets. As a star passes in front of a more distant star, its gravity briefly magnifies the background star's light. If that foreground star has a planet orbiting it, the planet's own small gravitational field creates a tiny additional flicker or bump in that light curve. By meticulously observing these fleeting microlensing events, astronomers have discovered ice giants, super-Earths, and even rogue planets adrift in space. Objects that would be impossible to detect through traditional transit or radial velocity methods because they are too far or too faint. It's a detective story played out across billions of miles, with light itself as the witness. And perhaps most astonishingly, gravitational lensing allows us to look back in time, to the very dawn of the universe. The colossal gravity of galaxy clusters can act as natural cosmic telescopes, magnifying the light from incredibly distant ancient galaxies that would otherwise be too faint to observe. Some of the most distant and earliest galaxies ever detected have been observed precisely because their light was magnified hundreds of times by a foreground gravitational lens. We're talking about galaxies that existed when the universe was only a few 100 million years old, offering a direct glimpse into the universe's infancy. Imagine peering through a giant cosmic magnifying glass, not just seeing things better, but seeing things that have literally been made visible by the bending of space and time itself. These revelations are not just incremental improvements. They fundamentally reshape our cosmic narrative. We are using the universe's own distortions to reveal its deepest secrets, from the invisible scaffolding of dark matter to the hidden worlds of exoplanets and the earliest whispers of cosmic creation. So, what does this all mean for our perception of reality? Gravitational lensing teaches us that the universe is not always what it seems. What we observe through our telescopes isn't always a direct, undistorted view. Instead, it's often a rearranged, magnified, or duplicated image, filtered through the warped fabric of space-time. It forces us to reconsider our understanding of distance, orientation, and even the fundamental layout of galaxies. This cosmic phenomenon acts as an omnipresent, invisible artist, constantly warping the canvas of the night sky, transforming distant lights into ethereal arcs and multiple ghost images. It's a testament to the profound and sometimes counterintuitive nature of gravity, confirming Einstein's audacious vision that mass doesn't just exert a force, but literally sculpts the universe around it. To this day, we are uncovering new lensed systems, each one a unique cosmic fingerprint, revealing more about the distribution of matter, the expansion of the universe, and the enigmatic presence of dark energy. The universe continues to play tricks on our eyes, but thanks to gravitational lensing, we're finally learning how to read its mischievous intentions. But it also leaves us with a lingering question. If the universe can so profoundly distort the light from objects light years away, what other fundamental distortions, what other hidden realities might still be eluding our grasp? What else might be right in front of us, but warped beyond recognition?